This video will give you an introduction to exponential growth and the equations that go along with that. The general equation for exponential growth is g of x equals a times 1 plus r to the x. A is the initial or starting value, the value when x is 0, when the time is 0. R is the percentage rate of increase, and x is the time, the number of time units that are under consideration. So let's do an example. Let's say the population in the year 2000 is 15,000 people in some city, and the growth is 8% per year. We want to know what the population will be in 2052. So we can write the equation or the function as follows. The growth function is going to be the initial value of the population, the initial number of people, which is 15,000, times 1 plus the rate of increase, and it's 8%, so it's going to be 0.08, to the x power, and x will be the number of years. Now we want to know what the population will be in the year 2052. Well, that's 52 years from the year 2000, so we will find g of 52. And in this case, that will be 15,000 times 1 plus 0.08 to the 52 power. And if you work that out on a calculator, that will equal 820,591. So that will be the approximate population 52 years from the year 2000. Next, we'll look at exponential decay. Exponential decay is where instead of growing at a certain percentage of growth per year, the value of something or the number of something decreases at some percentage. So we slightly modify the function, the growth function, to a, the initial value, times 1 minus r to the x, again where a is the starting value, r is the rate of decrease, and x is the time period. So let's take an example. A car is valued at $25,000 when it's new, and it loses 20% of its value every year. So the question is, what will the value of the car be in 5 years? Well, the decay function, and instead of using g, I'll use d this time, the decay function for x years is going to be a starting value of $25,000 times 1 minus 0.2 to the x power. And we can, of course, write that as 25,000 times 0.8 to the x power. If we want to know what the value will be in 5 years, we can find d of 5. That's going to be 2,500 times 0.8 to the 5th power, and that will be 2,500, 25,000 rather, times 0.8 to the 5th power, and that will give you $8,192. And there are just two examples of exponential growth and exponential decay.